My name is Hamid Charkhkar. I'm a research assistant professor at the Department of Biomedical Engineering at Case Western Reserve University. I'm also an investigator at the Advanced Platform Technology Center here in Louis Stokes, Cleveland, VA. In my laboratory, Restoring Lower Limb Neural Connection, or in short ReLLiNC, we develop novel prostheses for individuals who have lost their lower limb. What is unique about our work is that the prostheses that we develop directly connect to the nervous system, and it can reestablish the link that was once there before the amputation. Although existing prosthetic devices on the market can restore some of the musculoskeletal function, none of them connect to the nervous system. So in our group, we focus on restoring the neural connection. Using the technology that was developed here in Cleveland at Case Western Reserve and VA, we were able to interface with the remaining nerves in the lower limb of individuals who have lost their leg. We were able to successfully elicit sensations by delivery of electrical stimulation to the remaining nerves. We have shown that the recipients of this technology can benefit from the restored sensations while they're walking or when they're maintaining their balance. A major step is to transition this technology outside the lab into the home and community of these individuals with limb loss. To make this happen, we do need a user-friendly and simple interface that allows user to control the functionality of the device without relying on an expert. And at the same time, we should be able to collect data on how the system is being utilized without repeatedly ask the user to write down how and when they use the system. My proposal to develop a smartphone application for our neurally integrated prosthesis was funded through the Garbrick Incentive Program. In this project, we developed a user-friendly app that can connect to the prosthesis and our external pulse generator, and the users can control the delivery of electrical stimulation. They can adjust the perceived intensity of sensations, and they can do a full calibration process on their own. Throughout the process, we actively sought feedback from the end users on what features they would like to see in this app and how they should be implemented. Right now, we have completed all the steps for testing and design, and we are ready to actually use it during the homegoing trial. This project was critical because a poor interface can affect the perception of user from any new technology, no matter how good that technology is. We are now confident that using this app, we can thoroughly and effectively examine the effects of elicited sensations and this neurally integrated prosthesis during the activities of daily living.